just some, purified drinking water, or as I like to call it, H2O. What we're going to be talking about today is how something like this, and look at this guy, not a very small spider, but it appears that he is standing on top of water. Likewise, this paperclip, which if I were to take a bet, I would have said that paper clips sink. However, we see this guy here just floating right on top. So what we're going to demonstrate today is what this is that's happening. What is this phenomena that's happening? And it's called surface tension. So surface tension starts with cohesion. As we can see here, we have the definition of this word cohesion. It's the attraction of molecules for other molecules of the same kind, and water molecules have strong cohesive forces thanks to their ability to form hydrogen bonds with one another. And as we can see right here, hydrogen bonds of friendship. We have two water molecules in this image right here specifically. This is your oxygen and your two hydrogen molecules. And if you notice right here, they're the same molecule. So they can have cohesion because they're the same molecule. And they are bonding together right here. This hydrogen is bonding to the oxygen. Just kidding. This is the hydrogen and that's the oxygen. Anyways, we'll fix that. Because it's H2O. Oh no, it's H2, meaning that hydrogen is 2. I had it right the first time. I'm just tripping. All right. So we have these bonds that are going on right here. So when you get a bunch of them together, you're going to form a bunch of molecular bonds, which gives us water. All right, so water molecules are attracted to each other in all directions. We can see here that all these little dots represent water molecules, and every one of them is just trying to become friends with one another. So every single one of them is surrounded by another water molecule. So everyone is reaching out, everyone's trying to become friends, like Sweet Caroline. And then we come over here and look, when you get to the surface, there's not anyone up above to become friends with. So what happens is water molecules at the surface, they still form those bonds, those hydrogen bonds with their neighbors. However, because they're exposed to the air on one side, it's not the same molecule, so we're not going to have the same kind of cohesion. What we are going to have is a very strong bond because they're going to reach down. See how there's two hydrogen atoms right here? So it's going to have two bonds. It's going to form two bonds. It's going to form. So it wants to form two bonds, but instead of one going up, one going down, one reaching all the way around, they're both going to reach down in order to become closer friends with the molecules underneath them. So stronger bonds with the neighbors they do have. So when you get to the top of the water here, you're going to have a tighter bond, which is going to create our surface tension. So we are going to actually be able to look at what this surface tension, we can see an example of the surface tension when we're going to drop water on this penny. It's a flat surface right here, and it's going to create something, and you'll be able to describe the shape to me when you see it. Let's see. Speaking of tension, I guess. Oh no, see, look what I've done. Alright, we're dropping some water up on here, and look at this. Despite what I first did, because of the force of the water pushing it off, when I wasn't so forceful, it creates this dome. And the reason why it's not just spilling over at the edge, well, part of it is what we've been talking about, cohesion, and another part of it is adhesion that we'll talk about at a later time. But what we're focusing on right now is that this forms a skin almost. It looks like a skin. It's not really a skin. It's just really close, tight bonds as they're holding onto each other. Imagine that they're like trying to not fall over the edge. They're all holding onto each other super tight right up here on the top. And so it forms that surface tension until something breaks it. So this right here is possible partly because the force of the spider walking is not enough to disturb the bonds that are there. So if it is something significantly bigger, like your foot, it's gonna break the surface. We weigh too much. And the paperclip too, even though it's denser than the water around it, that surface tension is gonna hold it up because it's a little bit lighter, not enough to break it. But and we can try this, if you just boop, pop that surface tension, it's gonna fall straight to the bottom. So that is, that's it. We have cohesion, which forms these really close bonds with the water molecules. And at the surface, they form even closer, tighter knit bonds because there's not as many molecules to form bonds with. So it forms bonds with the ones next to it and below it. And it creates a stronger surface called